A NASA satellite passed over southwest Montana in the summer of 2019 and caught something that shouldn't have been there. A long green scar cutting through brown ranchland, 9 miles of it. Wet, living, glowing against the drought. 3 years earlier, that same stretch of land was cracked dirt and bleached cattle bone. A creek bed so dry the ranchers had stopped naming it. Now it held water again. And dams. Hundreds of them. Built by hand, not human hands. 23 animals had been dropped into that dead valley with no tools, no blueprint, no supervision. Within 36 months, they rewrote the geography of an entire watershed. The state biologist who tracked them still keeps the satellite image on his office wall. He says nobody believed it was possible until they saw it from orbit. Southwest Montana is not a forgiving landscape. The Beaverhead Deer Lodge region sits at the edge of the Continental Divide, where the land is wide, the winters are brutal, and water has always been the difference between survival and ruin. For most of the 20th century, the creek systems feeding into the Big Hole River watershed held enough water to sustain ranches, wildlife, and native fish runs. Then, the drought cycles began. Between 1988 and 2002, snowpack in the surrounding mountains dropped by nearly 31%. The smaller tributary creeks were the first to go. One by one, they thinned, then they cracked. Then, they stopped moving entirely. By 2005, a 14-mile stretch of Willow Creek, a tributary that had supported native cutthroat trout for as long as records existed, was reduced to a series of disconnected muddy pools. Ranchers in the valley watched it happen slowly. One cattleman, who had worked the land since 1974, later told a state wildlife officer that the creek didn't die all at once. It retreated, like something pulling back from a wound. By 2010, the riparian vegetation was gone. The willows and sedges that once lined the banks had dried out and collapsed inward. Without root systems holding the soil, the creek banks eroded. The channel widened and flattened, losing the depth it needed to hold water through the dry summer months. Wildlife surveys conducted by Montana Fish, Wildlife and Parks in 2013 recorded 0 beaver activity along the entire Willow Creek corridor. 0. A species that had shaped this watershed for thousands of years had been completely absent for over 3 decades. What nobody had yet calculated was exactly how much that absence had cost the land. The answer, when it finally came, was expressed in a single measurement that changed how the entire project was justified. The measurement was water retention, specifically how much rainfall the Willow Creek watershed was capturing versus losing to surface runoff. A hydrologist contracted by Montana Fish, Wildlife and Parks ran the numbers in late 2014. His report was 3 pages long. The conclusion fit in one sentence. The watershed was retaining 11% of its annual precipitation. 89% was running off the surface and disappearing downstream within 48 hours of rainfall. In a healthy beaver-active watershed, that retention figure sits between 54 and 70%. The creek wasn't just dry. It had lost the biological infrastructure that made water storage possible in the first place. The hydrologist flagged one additional detail that the project team later described as the turning point. Aerial thermal imaging of the creek bed showed subsurface soil temperatures running 8 degrees higher than surrounding ranch land. The ground wasn't just dry on the surface, it was desiccating from below. The proposal that followed was not immediately welcomed. A wildlife biologist named Tom Keene had been pushing the idea of beaver reintroduction in the Big Hole watershed since 2011. 3 consecutive grant applications had been rejected. One state official noted in writing that introducing beavers to a degraded creek was unlikely to produce measurable outcomes within any practical funding window. Keene filed a 4th application in 2015. This time, he attached the thermal imaging data and the water retention report. The application was approved in 6 weeks. But approval was the easy part. Finding 23 beavers healthy enough, wild enough, and geographically compatible with a creek system they had never seen took 2 years, 4 states, and one decision that almost ended the project before a single animal touched Montana soil. The decision that almost ended the project was about location, specifically where to release the beavers first. Tom Keene wanted to start at the Upper Creek section, narrower channel, steeper gradient. better conditions for initial dam construction. The rancher who owned that land refused access 2 weeks before the release date. No negotiation, no appeal process. The upper section was gone. The team had 72 hours to identify an alternative release point or lose the transport window entirely. The Beavers were already in holding facilities in Idaho. They chose the middle section, wider, flatter, less ideal. 3 wildlife technicians and Keene released the first 8 animals on the morning of April 3, 2016. The remaining 15 followed over the next 11 days at 3 separate points along the corridor. Then the team did something unusual. They left. No supplemental feeding, no habitat modification, no human presence beyond monthly collar checks. Keene later explained the reasoning simply. Beavers do not perform under observation. They needed the creek to feel abandoned. The first collar data came in after 30 days. 2 animals had moved upstream, past the refused property boundary, onto land the team had no access to. Keene contacted the rancher. The rancher agreed to let 1 technician walk the fence line with a GPS unit. What the technician found on the refused property was not what anyone had prepared for. The 2 beavers had already built a primary dam structure 114 meters long in 30 days on a creek that had held no standing water in over a decade. Behind that dam, a pool, 4 meters deep, already drawing in species the survey team had not seen in this valley since the late 1990s. But that was only the first dam. By the end of the first year, the colony had built 47 dams along 9 miles of Willow Creek. Not clustered, not random, distributed in a precise stepped sequence, each dam raising the water table behind the one before it. A hydrologist who revisited the site in April 2017 described the structure as an engineered gradient system. He had used that phrase before, but only for human-built irrigation infrastructure. The water retention figure that had sat at 11% in 2014 was remeasured in the summer of 2017. It had risen to 43% in 14 months. The subsurface soil temperatures that had been running 8 degrees above normal had dropped back to within 2 degrees of the regional baseline. The ground was cooling from below. Moisture was moving back through the soil column in patterns that hadn't been recorded here since monitoring began in 1987. Then the species arrived. Moose were first. 3 bulls recorded on trail cameras in September 2017, grazing willow shoots along a bank that had been bare dirt 18 months earlier. Sandhill cranes followed. Then a beaver surveyor, doing collar checks in October 2017, waded into a pool near the upper corridor and disturbed a school of juvenile cutthroat trout. Native cutthroat trout, a species that Montana Fish, Wildlife, and Parks had officially recorded as locally extinct in Willow Creek since 2009. Nobody had restocked them. Nobody had introduced them. They had come back through connected groundwater channels from a surviving population 11 miles downstream. Following the cold water the beavers had pulled back into the earth. The rancher who had refused access in 2016 called Tom Keene in November 2017. He asked if the team could extend the corridor onto his property, but by then, the satellite had already noticed. The USG's satellite image from July 2019 was the one that ended up in the report. 9 miles of green corridor cutting through brown drought, stressed ranchland. Visible, undeniable, measurable from orbit. The image was included in a federal brief submitted to the Bureau of Land Management in September 2019. That brief directly influenced the allocation of $4.2 million toward beaver reintroduction feasibility studies across 6 western states. Montana had spent $11,000 relocating 23 beavers. The return, measured in restored watershed function, recovered fish populations, and documented soil moisture recovery, was later estimated by a University of Montana environmental economics team at between $14 and $18 million in avoided restoration costs alone. 23 animals, $11,000. 9 miles of dead creek, rebuilt in 36 months. The rancher who refused access in 2016 signed a voluntary conservation easement in 2020 covering the Upper Creek Corridor, the same land he had locked the team out of. Tom Keene retired from Montana Fish, Wildlife, and Parks in 2022. On his last day, a colleague framed the satellite image and left it on his desk. He already had one on the wall. He took the second one home. The Willow Creek project is now referenced in watershed restoration guidelines across Canada, Australia, and the United Kingdom. Its core finding is simple enough to fit in a single line. A creek does not need to be rebuilt. It needs the animal that built it the first time to come back. If that idea stays with you, there are more stories here that the maps have not caught up with yet.